So now that we've talked through the steps that we're going to do for a hypothesis test for analysis of variance, let's do this for our example. So again, first is kind of refresh why we're going to be doing an analysis of variance test for this situation. So going back, we have this quantitative variable of weight loss that we're trying to compare among 3 different groups. So again, analysis of variance is for comparing a quantitative variable with 3 or more groups. So we really do only have 2 variables. One's quantitative and one's categorical, but the categorical one can have 3 or more options for analysis of variance to be done. In addition, we need these to be independent samples. So let's talk through actually why they're going to be independent. We have 57 participants, which we randomly assigned equally to one of the following. Now, what actually makes them independent? Recall from our previous module that we always assume the samples are independent until we know otherwise. So if we have 57 participants that we randomly assign, if I were to be in the no change group, from what I know, there is not a specific person that is going to be assigned to the diet group or a specific person that will be assigned to the exercise group. They're just being randomly assigned. So there's no reason to match, therefore they're going to be independent of each other. So now let's actually go through and do our 5 steps that we talked about in the previous video for our example. So our null hypothesis when we're doing analysis of variance is always going to be the same, and the idea here is that all of the population means are equal. In our situation, we had 3 different groups, so I'm going to have 3 different means. I'm going to use mu sub n for the mu of the nothing group. I'm going to use mu sub e for the exercise group, and I'll use mu sub d for my diet group. So our null hypothesis is that all of those are equal to each other. Our alternative hypothesis, again going back to our steps here, is going to be that at least one of the means is different. This was very different than what we saw before because there's no symbol or sign going on between any of the means here. So it's just at least one of the means is different. Our step 2 is the same as it's always been. So we will still reject the null hypothesis and instead believe the alternative hypothesis if our p-value is less than our significance level, which here was told to be 0.05. Our third step is our other big change. Here first we have our conditions. So looking at our conditions, the first one is that we need to have independent random samples. Now we did already just talk about why they were independent, so let's go ahead and write that part down. So our samples were independent because we had no known reason to match our participants. Now we still do need them to be random. So how were these 57 people chosen? Well, if you actually notice, it does not really actually say much. All it says is we have 57 participants. We don't really know how these people were chosen. However, since we're probably doing something that's regulated, kind of like a medical-ish trial, I'm going to assume that there's some regulations that go through for that. So I'm going to assume that those participants have been screened and all of those different types of things. All right, our second condition is that we need all of the populations to be normally distributed. Remember, this condition was different in the fact that it didn't have or a sample size to save us. So we need all those graphs to be normal. So going back and looking at our histograms that we had here. Recall that at first they didn't really look necessarily all symmetric and unimodal, but once we started comparing the means and medians to each other, we felt a lot more comfortable with describing all of these as being pretty or roughly symmetric as we were going through there. So for that reason, we'll feel comfortable in saying that things are normally distributed as well. So I'll just say that all of my histograms are unimodal. And pretty symmetric. Finally, this last condition we talked through that we're going to assume, but we are going to go ahead and write it down. So we're going to assume all the population standard deviations are unknown but equal. Our other part of step 3 is to get our test statistic. Now for this, I'm going to be using StatCrunch to help me. At the very end of the video, I'll show you how I got the StatCrunch output. Right now, let's focus on using what I've provided here for you. So for our test statistic, if I go back and look at our formula, is I want this MST over MSE, which is idea of a mean squared treatment over the mean square error. So what I can see here is I have this MS column, and then I have this error row. So this 5.34 number is going to be that bottom number for our MSE. The other MS, which is going to be labeled depending upon what I've named my variable, is going to be the treatment one. So for my F, I'm going to say that it's that 232.004 over the 5.3436 number. Doing that math, we're going to get about 43.4 for our F. Now, as a note, when we actually go to StatCrunch, it will give us this number, but I deleted it here, which I sometimes do on quizzes and tests as well, to make sure that you know how it's being calculated from the output. Now remember, F is very different from a Z or a T, so it's hard to kind of compare. But what we're trying to say is the larger this number is, really the smaller the p-value is going to turn out to be. So you notice here we actually get a very, very small p-value. So that actually brings us then to step 4. We are just going to get our p-value, which again will just be coming from StatCrunch. You will never have to calculate that. And it says it's less than 0.0001. So now going back up to our step 2, that then is less than 0.05. So I will reject the null hypothesis and believe the alternative hypothesis. So what does that mean our interpretation is going to look like? Well, if we follow the same format as usual, so our alpha is 0.05. We rejected the null, so there is our statistically significant evidence. To support. And then our last part is the alternative hypothesis, but in words. So that at least one, right, that's what our alternative hypothesis looks like up here. Mean weight loss is different among these three groups. So that's what our 5 steps look like. However, unlike many hypothesis tests that we've done, this one sort of leaves us kind of unsatisfied with this interpretation, because it's just telling me, well, that at least one of the mean weight losses is different. But that's not being very specific, and we talked that alternative hypothesis is really not that specific. So what could this actually mean? So this could mean, it could mean that dieting and exercising are equal to each other, but doing nothing is different. That falls into our category of at least one mean being different. It could mean that doing nothing and dieting is the same, but exercising is different. It could mean that doing nothing and exercising are the same, but dieting is different. Or all of the means could be different. Right? Each thing that we just listed off falls into that category of at least one mu or mean is different. So what I'd really like to know is, well, which one of those things is true? Which ones are different? And then more specifically, well, how are the ones that are different, how are they different? So that's what we're going to talk about in our next video.